Okay, I'm going to try my best to kind of walk you through this problem. So it says an airplane is traveling due east with the speed of 540 miles per hour. So here is my axis, and here is the airplane traveling east. 540 miles per hour. Then it says the wind blows at 70 miles per hour at an angle of 75 degrees southeast. So, not in respect to this airplane, there is a wind blowing at 70 miles per hour southeast. So I put the angle, I would say this is the angle here. It said it's at an angle of 75 degrees. So I go south first, then east, and I trap my angle. So that's how I know where the angle is. It's not over here, it's right under here. So all I have to do is just translate this over here. So once I translate it, I'm drawing this line so we know we can kind of create a 90-degree angle here and then that angle over there. I'm just translating this vector over here and putting the angle right back to where it goes. And we know that this is 75 degrees, okay? And it said it was at 70 miles per hour. Now our resultant vector is going to be this vector right here. Okay, we're going to call that A. We need to find that vector. And then the next thing we're going to look for is this angle theta. But let's find this vector A first. So we use the law of cosines and we say A equals the square root of 540 squared plus 70 squared minus 2 times 540 times 70 times the cosine of, well, the cosine of what? It's going to be the cosine of this larger angle, right? Because this is the angle, this large angle in the triangle is the angle that corresponds to this A side. And I need that angle, and I know it's 90 degrees plus the 75. So this angle here, we'll call it alpha, is 90 degrees plus 75 degrees, which is 165 degrees. So I'm going to say the cosine of 165 degrees. And I guess when you plug that all in the calculator, you get that A equals, what is it? 607.885. 607.885. So that's the speed, miles per hour. So I'm going to say 607.885 miles per hour. Okay, so now I found the magnitude. Now the next thing part B is asking for is to determine the angle of the airplane's flight. Okay, so it wants us to determine the angle of the airplane's flight, and this would be the airplane. This is our resultant vector. We need to determine the angle. So how do we get to the resultant vector? Well, we could take different directions. We could go south, then east. And if we went south, then east, like this, then we'd need to find the angle that's being trapped by that south, then east direction that we take. If we go east, then south to get to our resultant vector, then this theta is the angle that's being trapped there. So that's kind of how you can see this. Dad, can you stop? That's kind of how you can see this, is that you go east, then south, and that angle is being trapped there, or you go south, then east. Dad, can you stop playing with her for a second? South, then east. And then you'd need this angle. So let's find both. So how do we do this? We use the law of sines. The law of sines. So we say the sine, so we're going to look for theta first. So I'm going to set it up as the sine of theta over the opposite side, which is 70 over 70, equals this angle, the sine of this angle, which is 165, over the opposite side, which is the magnitude that we just solved for. So it equals the sine of 165 degrees over the magnitude, which we just solved for, which was 607.885. Now, you solve for the sine of theta using the cross multiplication. So we know theta equals the arc sine of 70 times sine of 165 degrees over 607.885. That is what theta equals. And then we find out that theta is, so theta equals 1.708 degrees. Okay, so I know that this angle here is 1.708 degrees. That's what theta is. So if I wanted to represent the angle in terms of this theta, I would say I go east and then south first, because that traps this angle into my, you want to trap this angle with the directions that you take and the resultant vector. So my answer could be east, what was it, 1.708 degrees south, or I could trap an angle another way using my resultant vector as the other side. I could go south, then east, and if I go south and then east, I still meet my resultant vector, so I've created a new triangle, and this angle is the one being trapped. And we know that that angle is, so I'd have to go south, then east, but we know that angle is just 90 degrees minus 1.708 degrees, so it would be, yeah, you could just do that, whatever that is, like, what is that, 98.3 degrees or something? South, 98.3 degrees east. You could also make that your answer, because that would give you this angle right here, which when you go south and then east, you're trapping that angle. So hopefully that makes sense.